Okay. So one thing we should understand very clearly, that any tool that exists within DevOps, it exists because it solves a problem. Similarly, Git that exists within DevOps, it exists because it is solving a very huge problem. So let us understand first the problem statements. Okay. So the main problem statements that we have, first of all, let us say that we need to work on a specific project. Okay. Let's call it as project one. The thing is, the number of developers who are going to work on this project are going to be 15, or 15 or more or less, somewhere like that. It's not like that only one developer is there who's going to work on this project. So first problem statement is that we need a system in which a multiple number of people can work very easily on the source code, on the application source code. First problem statement is that we need a system like that. Secondly, all those people should be able to collaborate. Okay, they should be able to collaborate. Third system is that since multiple people are working on a project source code, then it is possible that there could be different versions of the application source code, right? For example, let's say 5 developers are working, have created version 1 of the code, then other 2 developers, they have their own version, let's call it as version 2. So there could be different versions of the application source code as well. That means versioning should be possible easily. Okay. Force should be there since so many different people are working together. So people who are working together on this project source code, then it should not be like one person's work should not be affecting others. Okay. So it should not be causing any kind of issues to other person work. Okay. So these are certain problem statements that we have. And also another problem statement that we have, that for example, the client or manager or the architect who is managing the project, who is responsible for handling the overall project, should be able to see complete progress, what is going on, plus he should be able to track the work progress as well, like currently on what specific task everyone is working, or what kind of for what feature the code is being written. Okay, all these things should be very clear for the person who is managing the project. Okay, so these are our problem statements. Okay, so to solve this problem statement, we have a tool known as Git. Now Git is basically a VCS. What is VCS? VCS is version control system. Okay, now first thing that we get to know, version control system is basically a system where we can have multiple versions of the source code. In addition to that, we can have these features as well. Multiple people can work on the same source code together without affecting others. People can collaborate very easy. They can create multiple version of the code, and there could not be any issues. Like one person work should not be affecting others. Okay, so let us understand how Git is solving this problem. Okay, before that, one more thing we should be understanding: Git versus GitHub, or like uh, GitLab. Okay, firstly, Git is what? It's a VCS. VCS, version control system tool. While these are basically a hosting services. Okay. When I say like hosting services, so what does exactly, like what do I mean by this hosting services? So these GitHub and GitLab, they are built on top of Git. Okay, that means they are following the Git whatever rules and regulations is there in Git, that is being followed by GitHub and GitLab. So when I say hosting services, that means these are basically providing specific storages. Okay, specific storage available so that we can store our source code. Okay, and managing the source code can be done using Git. Okay, so Git is VCS, version control system, while GitHub or GitLab or Bitbucket, they are hosting services built on top of Git, which are going to help us manage our code. Okay, and in addition to that, they are also going to provide us some storage so that we can keep this source code there. Okay, now there are two kind of VCS. When we talk about version control system, there are two kind of VCS. One is CVCS, second is DVCS. Okay, these are short for centralized version control system, and this is distributed version control system. What exactly is the difference? So difference lies in the name itself, centralized. That means there are two formats of the like code will be there. One is going to be the remote repository. Remote repository means the repository or storage where we are keeping the source code is kept somewhere else on some sort of cloud. Okay, while second one will be there the local code, a local version of the code, okay, which will be on our own machine. Similarly, here also it's going to be one remote repository and there will be one local repository. Okay. Now, what exactly is the main difference? So when it says centralized, that means there is only one central server where the source code is kept. Okay. While in distributed system, there will be like a remote repository will be there. But in addition to that, all the people who are working on the source code can have the local system. They can have a copy of this code directly on their local machine as well. Everyone, like developer one will have the local copy of the exact replica of the source code. Developer 2 is also going to have the local copy of the replica, the remote repository. Okay, that means ki even if we have some issues here in remote repository, still develop other developers who have created local copy of the source code, they can work without having any issues. Okay, for example, let us understand a scenario that we have kept our source code on specific repository on GitHub. Okay, for some reason or for some issue, this repository is having some issues and it went down. Okay, it's not working right now. Okay, meanwhile it is not working, so GitHub team is fixing it at this point. So meanwhile it is getting fixed, it is not affecting the work of developers who have already created a local copy of the actual repository here, and they can directly work here without facing any issues. Okay, another scenario, let us say that this remote repository it is deleted. Still, since each developer has a exact copy of the remote repository, so they can simply push it again, and like this repository will be available again. Okay, and at this point almost everywhere they are using distributed version control system. Why? Because it has much better options. Everyone can work properly, everyone can collaborate without causing any issues. While in central version control system, the thing is the remote repository that exists, so if any developer want to work, if any developer want to push any changes, they have to first create a copy in their local machine, make the changes, then push it back. Okay, so it's like they cannot have the local copy, or they can have very like limited features to work in local. So every time they have to work they have to like push any kind of changes or make any kind of changes on the report repository, they have to create a copy of it, make changes, and then push it right now. Okay, and if this server is down, the central server, then developers cannot work on their local machine. Okay, that is the one of the main differences, that everything is dependent on the central server. If it goes down, everything goes down. While here in distributed version control system, even if the central server or the repository, even if it goes down, still developers can work with the copy of the code that they are having in local. They don't have to always rely on the remote repository to make any kind of changes. They can make any kind of changes in their local copy also. Later they can push on. Okay. So first of all, what problem does Git is solving? First of all, it is making sure that multiple people can work on the same source code without causing any issue. Secondly, everyone can collaborate also, so that like if they want to merge their work, they can also they want to combine their work, they can also do that. They can create they can do versioning, and there is no issues if multiple people are working on the same source code. Okay, and managers can track the work progress very easily, what is working and who is working on what features. So let us understand how Git is solving these things. Okay, so first we have how multiple people can work on the uh, same source code. Okay, so as I say, ki there will be one like remote repository where we are going to keep our source code. Okay, let's say this is the source code S1. So if there are four developers who want to work on this, what they can do? First developer, they can create a local copy, a clone of this repository. Okay, let's call it as local code one, and this is being worked by developer one. So developer one, what he did, it created a local copy of the remote repository and started working on it. Similarly, developer two is there, who also created a local copy of the remote repository, and he created a copy of that, and he's working on this feature. Similarly, third person, who is like a developer three, he is also created a local copy of remote repository and is working. So at this point, they are working everything on their local machine, and whatever they are making changes here, it's not causing any issues to the second developer, because each one is having a local copy on their own systems. Okay, so in this way multiple people can work. talking about how collaboration can be done. For example, let's say we have two developers, developer 1 and developer 2. Okay, so developer 1 has written a code for adding a new button. Okay, let's say button B1, while developer 2 has written a code for some other feature who's written, let's say he has written button 2. Okay, now since they have written the code in their local machine, they have written the code in their local copy of the repository. Now they want to like collaborate, they want to make sure that these changes are like both the changes are visible on the code. Okay, so what they can do, here, this is my remote repository, this is developer 1, this is developer 2, and his code, let's say this is code 2 and this is code 1. So now they want that this changes, the code 1 changes also and code 2 changes also, both of them should be combined here. So both the changes should be applied here. So using a feature known as push, what they can do, they can simply push their code directly here. Okay, they can put their push their code directly here, which, so these changes, C1 change will be added to the remote repository. And just to again telling, remote repository is nothing, it's simply actual code that we are keeping on some server like GitHub or GitLab. That is where the remote, that is what the remote repository is. Similarly, once developer 1 has pushed their changes to remote repository, similarly developer 2 is going to push the changes on the remote repository. Okay, now one problem that we might face here, that before pushing any kind of changes, because let's say that there are 3 developers working. Okay, and developer 3 has written code C3. So let's say at 10 a.m. developer 1 cloned the repository. Similarly, let's say at 10 a.m. 10 a.m. past 10 minutes, developer 2 has cloned the repository. Okay, so at this point there was no the code that developer 1 cloned and the code that developer 2 has cloned is same. But at 10:15, developer 3 added some feature here. Okay, C3. Now the code that developer 1 is having and the code that developer 2 is having is not same as the remote repository, and they want to push their changes. So what they have to do, before pushing changes, first they have to run the command git pull. What it's going to do, whatever new changes have been added on the remote repository, that will be copied or that will be updated in their local version of the code as well. And once that is updated, then they can run the command push. That means first they have to fetch the new changes that has been added to the repository, and then they have to push the changes of their own. Okay, talking about the third feature that git provides is versioning. Okay, so how versioning will be done? So there is a concept of branches. Okay, in GitHub, in Git and Git like repositories. So basically, let us say that this is my repository on GitHub. Okay, inside this, let's say at this point, 3 developers, D1, D2, and D3, they have added the code that is version 1. Okay, later on, what we realize that, okay, we have to add some new features. Okay, so it is said that developer 1 is supposed to add feature F1, developer 2 is supposed to create a feature F2, and developer 3 is supposed to create feature F3. Okay, so what they are going to do, they are going to create 3 branches from the main branch. Okay, let's say this is the actual code, our latest and updated code. So this will be a branch known as main branch. Okay, now developer 1, what is going to do, he is going to create a new branch known as feature 1. Okay, now at this point, when developer 1 cloned or created a copy of the main branch, it is same, it is containing the code that is kept here, like same code, version 1, it is also version 1. But after this developer has added new code, then this will be different version, let's call it as version 2, because new code is written for feature 1, so this will be version 2. Similarly, developer 2, they have cloned again the main branch, and this time new branch that they created is feature 2, and then they added code for feature 2, so this will be version 3. Similarly, developer 3 cloned the repository from main branch, and they have written in the local copy, they have added new code which is feature 3. So this will be branch name feature 3 and the version will be version 4. So in this way, each developer has a different version of the code. Okay, so versioning can be done very easily using branches. If you have multiple branches, then each branch can contain different code. Okay, and if two branches are containing different code, it's not causing any kind of issues to the other branch. Okay, so general branches that we have main branch. Main branch is the branch that contains always the production ready code. Production ready code means this is the latest and updated code that contains that we can directly use to deploy the changes to our production environment. Okay, then we have dev branch, which is the development branch. So whenever some new feature needs to be added, some new task needs to be done, that piece of code is added to develop branch. Okay, dev branch or develop branch. And that also directly we are not like writing the code here. What we do, we create a branch from here. Generally we call it as feature. So if there are multiple developers, they can create their own feature branches. Let's say this is d1, this is d2, this feature 1, feature 2. Two feature branch will be there which developers are going to work, and if code is written correctly, they are going to combine it back to dev, combine it, or you can say merge it. Okay, similarly, if developer 2 has created new branch, feature branch from dev branch, and everything is working fine, then they are going to merge it back to dev branch. Then we have qa branch. QA branch basically contains the source code which we are going to use to deploy to QA environment or quality assurance environment. Okay, so mainly in this QA environment, we have the code for different kind of testing, specifically functional testing. Then we have PPD branch. PPD branch is pre-production branch. So before we deploy the application, before we deploy the source code directly to prod, before that, there will be a version of the code kept in PPD branch. Okay, I'll explain in a bit like why exactly we are having PPD branch. Then we have DR. DR is short for disaster recovery branch, and disaster recovery branch generally contains same code as the main branch. Okay, so these are the general branches that we have: main branch, dev branch, QA, PPD, and DR. Okay, now let us directly get started with the hands-on part so that we can create repository and manipulate and perform different kind of things. Also, since we are going to work with GitHub, so the for authentication, like long ago, we use like user and password. But at this point, almost everywhere you have seen that instead of using password and username, we use either we use like just a token, or we use user slash token, like both of them. Okay. So here also in GitHub, we can use just token, and that is like more secure way version, secure way to work with GitHub. Okay. So first thing what we can do, we can go here. This is an account where we are going to perform everything. Okay. So let us say that I want to create a repository. I want to keep my source code there. So for that, I'll click on new repository. Let's provide a name. Let's say call it as project. Whatever name you want, you can keep it. Description is optional, and we can keep the project repository private. Okay. Now repository is similar to like a folder inside which we are just going to keep our source code. So let us keep it private, and we have this readme file. So what is readme file? Readme file is basically a file that contains information about the project. Whatever information you want, you can just put it here. Information like what is the structure of the project, like how to run the project, this kind of information we can have. Git ignore file, this will be explained later on, but from the name you can understand git ignore. It's a specific file that we are telling to Git to ignore the specific specific kind of contents that should be ignored from the repository. Then we have license. So if you want that your project should not be used for like commercial purpose or specific reasons, you can choose specific license, but generally we go with MIT license. Okay. And by default, you can see there is a one branch getting created, which is main branch. Long ago, we did not have main branch. Instead, we were just having a master branch. But almost everywhere now, master branch is directly referred to as a main branch. And main branch is what? That the branch that contains the code for production ready code for that will be used for deployment. So we can create this repository. Okay. Now this README file, first of all, if I click on this edit, you can see it's a format of MD. MD is markdown format. Okay, so whatever things we want to write, we can write it that in the format of markdown. Now, as I say, it is a private, and if you want to make any kind of changes or push anything here, we have to first connect to it. How do we do that? For that, first of all, you have to go here, your profile, scroll down to settings, and here scroll down to developer settings. From here, we have to create token, where third option we have PAT, which is personal access token. You can click on classics. Let me remove the older token. Now, here we have to create new token. We can again select the classic, and here we have to provide the password. Now, here we can give a name. Okay. Here you can select like what kind of expiration will be there, like for how long the token will be valid. And here you can give the scope. Scope means like for what purpose this token will be used. This is one of the biggest difference between using username password and using tokens, because in tokens you can create multiple tokens with different level of access. And for example, like you can create one token that has only read only access. So that token you can share to people for whom you want that they should be having just read only access and no write access or no like any other access. So based on your requirement, you can choose the scope. For example, generally just for initial time, I'll just go with all the access except delete packages and except the delete repo permissions. Except these permissions, I can give other permissions, and then we can perform almost all the things except deleting the repository. But again, this depends on like project requirement, and here what each level of access is going to give, that is written. Okay. Now we create token and we have to copy it and keep it somewhere because it won't be visible always. So I have copied it and we can keep it here. So once we have token, then we are good to go and we can then like connect to our repository for that. So now we are here. Now next thing that you have to do, you have to download a tool which is known as Git Bash. It's a freely available tool. You can click on first link and you can download it. Whichever machine you are having, Mac OS, Windows or Linux, you can download it. On Linux by default it is already present, but for Windows you have to download it. And if you are generally if in your company it is not allowed to download anything, you can simply go with portable version, but generally just go with 64-bit Git for Windows setup. Once you have installed it, then you are good to go. And now you can go to any specific location wherever you want, right click on some more options and click on Git Bash here. So this is the terminal that is going to open when you have installed Git Bash. And now first requirement is that we want to create a local copy of the repository. So for that we can run the command git clone, then repository URL. So repository URL we have is this one. There are like these two are like most widely used, SSH and HTTPS, but generally we use HTTPS only. It's much more and it's like much better. And here we can paste the URL, click enter. And now as soon as if you do it for the first time, it's going to give you this kind of pop-up, connect to GitHub. Either you can sign in or you can just go with token. Okay. Also, it is possible that if you're doing it for the first time, it might give the error like fatal, like authentication not provided, something like that. But just run the command again and that error will be gone. Okay. So now we can just use the token that we have created for our account, paste it here. And now this will be authenticated. Okay. So you can see here that we are able to clone. Now, one more thing that I need to show you on Windows system, that credential that we have just added. So that will be stored on this section, credential manager inside Windows credentials. Here, if I go here, you can see your username and password will be added. So if you want to remove it, if you want to edit it, you can do it from here. Okay. Now, one thing you should be able to notice that we have just cloned the repository, and if I run ls command, now we have a folder project. If I go inside this, one change you will see. As soon as I go inside this project folder, immediately here main is written. It shows that currently we are on main branch. Okay, but how does Git understood that we are currently in main branch? So that because if I go inside it, you can see there is a hidden folder. You can see the folder name is .git. Okay, so if I go inside it, it has different files and folders that are necessary for Git to work, and all the information about the project will be stored here. Information about the project, about the repository, not the content of the repository. So as soon as we go inside this folder, Git is able to find this folder .git, and from there it is able to fetch the information that currently we are on main branch. Okay, and if I run ls, so we have two files created, right? A license and readme that we have created on the remote repository. So now let's create another file and let us try to push the changes. Okay, now before you like make any kinds of changes, what happens if I show you? Okay, let me show you first. So in order to create some new file, let's say I want to create some new file, so I can create by using touch and let's say I want to create a file 1.txt. Okay, I have created. Now using vi command, I can edit this file, and here I can, let's say, write Aditya Jaiswal, save this. Okay, and here one command, if I run git status, here you can see after running git status, it says that there is one untracked files. Okay, there are two kind of files that will be existing in our local repository. So one is going to be tracked, one is going to be untracked. Okay, so before, in order to make you understand about this, let me understand the exact process how we push any kind of changes to repository. Okay, so let's say this is my local copy of the repository. Okay, here I added one new file 1.txt. Okay, I have created new file. So next step would be to add it to git. That we can do using the command git add. We can write 1.txt, or if we have multiple files and if you want to add all the files in one go, you can simply write git add dot. This means that we are add, dot means current folder, right? So whatever new files are present in the current folder, all of them will be added to git. So this will be the second step after we have created the files and written something in. Next step will be to commit the files. Okay, commit files means that we are confirming that these files are ready to be pushed to the remote repository. So for committing files, we can run the command git commit -m for message, because if you want to commit files, basically if you want to push some files into remote repository, others are also going to see. So we need to make sure that they are able to understand uh, for what reason new file is added. So here, for example, I can write feature code. Okay, and final command is going to be git push origin, then branch name. In our case, it's going to be main. Okay, so here when we have just created the file and written some content into it, then we say that that file is untracked by git. Okay, git is not aware about the file, it is untracked. But when we run this command git add file name or git add dot, then that file becomes tracked file. That means git is aware about that file. Okay, now coming back here, so here one file is added, right? So next step would be to add it. For that, I can run git add dot, or we can simply write git add 1.txt. Okay, but generally we write git add dot so that whatever files are there, we can add them, all of them in one go. Okay, now that is done. If I run this command again, git status, now it says, you can see that it shows in green. That means this file is tracked. This file now 1.txt file is a tracked file, and it is being tracked by git. Okay, so now we have to commit this file. For that, I can run the command git commit -m for message. We can write the message like added 1.txt. Now this file is committed and it is ready to deploy, ready to be pushed. So for pushing, we can write git push origin main. Here origin basically refers to the branch. Okay, here we are writing to this branch we want to push, so we will write this and click enter. And now it is going to push it, and we can verify these things by refreshing the page. So 1.txt is added. Okay, so this is the simple ways for creating new files, modifying it, and then pushing it. Okay, now talking about like the different versions of the code. So for creating different versions, we have to create branch. So creating branches, we can do it manually from here. For example, see, we can add files also, create new file. We can provide like, let's say file name also, let's say 2.txt, and here we can write GitHub. Anything we can write, and we can commit the message, commit the changes. We can write some message here and commit the changes. Okay, these files is also added. Now here now there is a difference, right? Because on remote repository we have added 2.txt, a new file, while here we have not added the same file. So if here I run ls, we can see just 1.txt is present. Okay, so how do we get the like how we update our local repository so that it is in sync with the remote repository? So for that, you need to know two commands. First command is fetch, second command is pull. Now, what exactly is the difference? This is some question that is being asked in interviews also. So fetch, what it does, it's going to update only .git folder. What I said .git folder was .git folder was a folder which contains information about the repository, branch configuration, and other information about the repository, but it does not contain the application source code, right? So when we run the git fetch command, it's just going to update the local repository by like in providing the information that some new file is added on the remote repository. But that file won't be added. That means in our local repository, 2.txt is not added yet. Okay. But if you want to add those, basically, if you want to make our repository in sync with the remote repository, then we have to run the command git pull. Git pull, what it's going to do, it's going to make our local repository in sync. In sync means whatever new changes or new things are added on the remote repository, those things will be added to our local repository also. That means now 2.txt file, which is the new file on the remote repository, will be added on local as well. Okay, so let me show you that as well. Now if I go here, 1 second. Okay, here .git folder, it is updated on 20 this, right? So here if I run this command git fetch, okay, some changes done. But if I go back to repository, here you can see, let me refresh the page. Okay, here 2.txt is not at all added. 2.txt is not yet present, but some changes have been done. Basically, it updated the .git folder, telling that okay, some changes are added, some new changes have been done on the remote repository. Now, if I run this command git pull origin main, okay, so it's saying that now there are some changes and we need to merge those changes in our local repository. So we can simply save this. Okay. Now if I run ls, you can see 2.txt is added now because after running git pull origin main. Okay, or git pull origin main or git pull also you can run. That will also work fine. Okay. So for updating local repository, we have to run git pull. But git fetch is also there, which is just going to update .git folder or just update the information that some new files or some new things are added on the remote repository. Okay. Now, talking about how we can create different versions of the source code. So for that, we have to create branches. Okay. For example, currently I am on main branch. So in order to create a new branch, I can run the command git branch, sorry, git branch and branch name that we want to work with. For example, let's say I want to create a new branch named develop. Okay. So we have created branch. How do we confirm? If I run this git branch and if I run -a, click enter. So here what you are able to see, this red thing that you are seeing, that is the remote branches, remote repository branches, the branches that are available on the remote repository here. Here we are just having one branch, right? While here, what you are able to see, one like this is the local. This green and white, they are in local branch. So locally, what we are having main branch and develop branch that we just created. Okay. So using git branch, you can see it. And if you just want to see like remote branches, you can run git branch -r. And here it's just going to see the branches that are on remote repository. For just the local branches, you can run git branch and it will show the local branches. Okay. So now we have created new branch, develop branch. How do we switch to it? So for that, we can run the command git checkout, then name of the branch. And as soon as we run the command, we can see that this is new branch. Okay. This is new. Now currently we are on develop branch. Okay. Now, as I said that it is also easier to see like what changes have been done. Like git can also be used for tracking the changes, right? So how it can do that? For that we have a command git log. If I run git log command, it's going to give detailed information, but generally this is quite long and we don't have to go in very deep. So what we can do, we can simply use the command git log --one line. This is kind of, it's also going to give the logs, but it is very user friendly format. And here you can see these are the like commit IDs, you can say, or some specific ID to like identify the commits. So as of now, we are having 4 commits, right? Initial commit, then added 2.txt, then create 2.txt, right? Like that. Now, let's do one thing. Let us create more files inside develop, and then we can push the changes, because as of now branch is created, but this branch is not present here on the remote repository. Means local branch is not in sync with the remote repository. Okay. So what we can do, let's create few files. I can run touch read.txt. Then let's say git add dot git commit -m. Then let's say we can write added read.txt. And let's create one more file. Okay. So now we have like created a new branch. We have added some files and we have committed it also. And if I run this command git log hyphen hyphen one line, so we have these new changes added, new commits added. These are the new commits. Okay. This thing that you are able to see head means this is the latest commit, latest changes that has been done on the code. That commit is shown by head. Okay. Now I can run the command git push origin. Here we will write develop. Okay. Why? Because currently we are on develop branch. Okay. Now we can go here and now we can verify the changes. If I just refresh it. So now we are having two branches. Second branch is develop, which has some new files 3.txt and 4.txt. Okay. So this is how we can create branch, modify it, and we can push the updated branch to the remote repository. Okay. So this is like creating, right? But there should be some option for deleting as well. Correct. Now I'm going to run the command. I'm going to create a new branch from develop. So I can run git branch feature. Okay. And I can switch to git checkout feature. Now, since I was on develop while creating the feature branch, that means my feature branch is going to contain the same code as the develop branch. And at this point, you can see 3.txt, 4.txt is present in feature branch as well. Okay. Now I want to delete this feature branch. So for that, I can run the command, and I want to delete it from here as well as on local also, on remote also, if it is present there. So I can run the command git push hyphen hyphen delete. Sorry, git push origin. Git push origin hyphen hyphen delete. Then branch name, which is feature. Okay. Now, why it gave error? Because we were trying to we were trying to use this command to delete the remote repository, but this branch is not at all present on remote repository, right? This is present on just local. I can confirm by git branch. Here we can see feature branch is present here, and green star, this shows us currently we are on this branch, but this branch is not present on a remote repository. So if you want to delete it, we can run the command git branch apples. Okay, you can see it is not giving us option to delete it, but if I change here to capital D. Okay, because generally this capital D denotes like for to delete something with by force. Okay, I guess we are already on feature branch. Let me try this. Git checkout develop. Okay, so since we were already on feature branch, so it was not giving us an option to delete it. But as soon as we switched back to develop branch, then it was able to give us the option to delete it. And if we have, for example, let's say git which branch, let's say feature one. If I create some new branch from develop again, and if I push the changes, git push origin feature one. Okay, let's wait for this. So basically now what I'm doing, I'm trying to push the branch on the remote repository. Like feature one should be present on remote repository. Okay, feature one is present now. So now if I want to delete it from local as well as on from the remote repository, then we can run the command git push origin -- delete feature. Okay, one second. Sorry, feature one. And this is going to delete it from the remote repository as well. Okay. So this is how we can work with we can create different branches. And one thing you can understand, which on whichever branch you are currently existing, from there, if you create a branch, then new branch will be having the same content as this. For example, if I create a new branch from this, like currently we are on develop. So if I'm creating some new branch from here, then that new branch will be having the same code as develop. Okay. Now, one thing now what I want to show you, I want to explain you concept of merge and rebase. A merge, like concept of merge and rebase is one of the most important topic that they ask in interviews. So let us understand with example. Okay. Now, one thing very clearly I'm saying, in companies, rarely they will use rebase. In companies, mostly they are going to use merge, and explain the difference, like why exactly they are using merge more and not like rebase. Rebase is like very less, very less they are going to use. Okay. So let us say that we have our repository in which we have done multiple commits. Okay. Let's say this is commit one, this is commit two, this is commit three. Okay. And after committing second after committing the second time, we created a new branch from here. This is our currently main branch. Okay. We created new branch, let's call it as develop. Okay. And we added two new files. Okay. 3.txt, 4.txt. Okay. And here also in the main branch we are making our own changes. Okay. Now later on what happened, that we decided that okay, whatever changes we had to make in the develop branch, we have done that. Now we want to merge these changes, combine these 3.txt 4.txt new file inside main branch. So what we have to do, we are going to run the command git merge develop. And this command we have to run on the branch where we want to merge. For example, I want to merge develop to main. So first I have to go to main branch, and there I have to run git merge develop. That means I want to merge develop branch into main branch. Okay. So when I run this command, what is going to happen? Commits are going to create it. First commit is going to be 3.txt. Second commit is going to be 4.txt. Correct. But in addition to these two commits are the actual things that we have done, right? But in addition to these commits, there will be one more commit added. This commit will have the information saying that merge has taken place. Okay. So here you can see that history is preserved. What kind of history? History is basically the information about that these last two files, they have been added through through merging. Okay. Even though we were having just two files, two commits. So still while running the git merge command, there will be three commits added instead of two, because two commits for the 3.txt 4.txt, but one addition commit will be added which says that merge has taken place. And that's exactly where the difference lies between merge and rebase. If I run the command instead of git merge, here if I run git rebase, and here if I run the command like develop, okay, then what is going to happen, in there will be two commit created. Let's say this is our main branch. Okay. 3.txt 4.txt. Okay. And there won't be any there won't be any additional commit. Only two commits will be there, same as what was in develop. So here what we are basically what is being done, clean history. Okay. And you can see the problem, because in companies in DevOps, if you are working with git branches, if you are working with like managing source code, then obviously we need to understand how, from where new changes have been done. So if new changes have been done from some different branches, then we should be having some information that okay, these two changes have been merged, they are coming from the merge. While in rebase, since there is no extra commit, so we cannot understand, we cannot say that these two changes 3.txt and 4.txt, they have been added from like some other branch. Okay, so here history is preserved, while here history is not preserved, and here it's very clean. Okay, even though we can say it's clean, but obviously you can understand very clearly there is no proper tracking will be done for the like changes that are coming from different branch. Okay, that is the reason in companies they are going to have they are going to perform merge request only instead of rebase, because it provides the proper information that okay, merge has been taken place. Okay, so let us see this in hands on so that it becomes more clear. Okay, so currently we are on develop, and I can see here git log hyphen hyphen one line. So here our latest commits are these two, 3.txt and 4.txt, and commit code you can see this one. Okay, if I go back to git checkout main, and here if I run git log hyphen hyphen one line. Okay, so currently here 3.txt 4.txt is not present, and we want to merge the changes from develop branch to here. So we know ki, okay, two new changes are there. These two new changes are there, while in main you can see A208, that is up to here. That means two new changes are there that we want to combine or merge. Okay, so if I run here, that means ki, you know what is going to happen if I run the command git merge and merge the changes, right? So what is going to happen basically, on three commits are going to be added, one commit in addition to these two. Okay, and let us run git merge. And again, I'm saying ki if I want to merge develop into main, then first I have to go to main branch, and there I have to run the command git merge develop. And here we have to give some information. We can give information like develop added 3.txt and 4.txt. Okay, I can provide a message, save this, and changes has been taken place. Okay, and if I run now git log hyphen hyphen one line, here you can see in addition to 3.txt, the exact commit, and 4.txt from develop, one new commit has been added, where it shows a message that okay, two new changes have been added, but they have been done through merging. Okay, so this is how merging will be happening. You just need to remember that additional commit will be added in merging, which provides the history information from where the files are added. Okay, similarly, let's say I will push these changes, get push origin main. Okay, changes are pushed. Now let us see rebasing. So for rebase, as of now we have get log hyphen hyphen one line. We have these things, right? We have two new things are there, some new commits are there. So what I'm going to do, I'm going to create a new branch from this git branch, or maybe directly we can do it through develop only. Okay, I can switch to git checkout develop. Okay, and let us create some new files. I can create touch 5.txt, then git add, git commit hyphen and then git 5.txt. Okay, similarly, I can add another file, touch 6.txt, git add dot git commit hyphen m, then let's say added 6.txt. Okay, and then we can push these changes to develop. Push origin develop. Okay, now in git in develop branch we have these new files, one line. Here we have two new commits added, this and that. Okay, now in merge what happened, there were one extra commit added, right? So this is what we are going to check now. I can switch back to main, let's check out main, and now I can run the rebase command. So I can run git rebase develop. If I run this, it is done. If I run git log hyphen hyphen online, now here you can see two latest commit. This one added 6.txt, 5.txt. Same thing is added here. Added 5.txt and 6.txt. Now it won't be very easily possible through extra commit that some these new files that are added, they have been added through merging, they have been like combined. Okay, so here no extra commit you are able to see. Okay, this is the main difference. And again, I'm saying that in companies they are going to prefer using merge because it provides clear information about how like changes, new changes have been introduced, how new changes have been added to the specific branch. Okay, rebase is good if you want to have a like very clean history, you don't want to mention that these changes have been published from different branch, then you can go with rebase. Okay, one more thing, in companies, generally we don't run command like git merge this and that. In companies, what is going to happen, for example, let me refresh the page, wherever they are going to keep the source code. For example, they have dev main so and so. Okay, so let me do one thing. Mm, let me create some new branch. Let's call it as feature, and I'm creating it from develop. Okay, and let us add some files into it. 8.txt. Sorry. Okay. So now, if you want to merge these changes, what we have to do, we have to click on this option, pull request. Now, pull request is a kind of option that will be present in everywhere. Okay, in any kind of repository that you are using, this pull request option will be available. Let me see if I can show you from Azure DevOps as well. Okay, so I'll show you. Maybe I'll add a small video on that because I don't remember the password right now. Okay. So generally what we happen if you want to merge any specific branch, let's say feature branch to develop branch or other branch, we have to click on pull request. And here we have to click on new pull request. So here, let's say I'll click on feature. Okay. So basically what happens that whenever we want to merge, so we are going to go with pull request. And why this option is better? Because we can click on like here, all the information will be added that what new changes are going to be added. So if I click on create pull request, on the right side, you'll be able to see some option like reviewers. See, the thing is, as I say that there will be branches like main, dev. So as I told you, main branch is the branch which has the production ready code. And this main branch, if it has production ready code, then nobody wants that any new people, new employee of the project or someone else should be interfering with it. So whatever changes are going to be like added in main branch, they are going to be pushed here after they have been verified. Verified by whom? Verified by the architect. So if we have added some kind of changes in develop and we want to merge those changes to main branch or any other branch, that change, that merging should be verified by some architect or the whoever person is leading the project. That's exactly happens. For example, here if I want to merge something from feature branch to main branch, what I have to do, there will be some people who will be added as a reviewer. Okay, like whoever part of project will be added here in the form of reviewer, and that person is responsible for merging, for verifying the changes in the like feature branch code or whichever branch code. Then once that like verification is done, then only merging is going to happen. But the person who has raised the pull request or merge request has to provide all the information here, but here that we have added these kind of changes in the develop branch of feature branch and now we want to merge. Then we have to click on create pull request. Now once that pull request is created, then that person, the architect or the person who is leading the project, is going to verify the changes. These things are added 8.txt, 6.txt. He will be going through the code, checking what changes have been done. And once he has like verified, okay, there are like this is fine and there is no issue, uh, This is the specific concept, the conflict concept, which will be added separately. So once verification is done, okay, everything is fine, then only the architect or whoever is reviewer of the code is going to click on merge pull request and merge the changes from one branch to other. Okay. And generally, if you have like feature branches, like because feature branches are like very temporary kind of branches, so we have the option to delete them as well. Okay. And now merge has been completed, and now we can go back to main branch, and here we can verify the changes. Okay. So this is how merging happens. Generally, here I explained that how we can run the command get merge and all, but generally in companies it's going to be happening through pull request only instead of running the commands, if instead of just running the commands on this git bash or so. Okay. Now, so git merge we understood, and git rebase we understood. Okay. So let me explain you some other concept, which is stash and pop. Okay. So now stash and pop, what is the concept of it? First, let me explain, then we'll do hands-on. Let us say that uh, we have our source code present. Okay. We have our source code present where we are writing code. Okay. So what we did, first command we ran touch, let's say a.txt. We ran this command. Then we ran, sorry, give me 1 second. So next, let's say I want to edit this file. So I'll run the command vi, then I ran the command a.txt, and it opened the editor where we can start writing the content inside this file. Okay. And I have written some file, and let's say I wrote something, let's say Aditya Chaiswal, and then I ran the command git add dot. That means I asked git to track the file. Okay. After that, I just realized ki, before this file, I had to add another file b.txt that is supposed to be added before that. Now, after adding the file, what step we do? We do the step of git commit, right? So here, if I now create this file and now if I commit files, then both will be committed. And if that is like these two files are getting pushed into the repository, then that is not the requirement, because our requirement is that we have to create this file first before a.txt, and then we have to push these files, right? So in that case, what we can do after we have run this command git add this, then we are going to run a command git stash. So what this command is going to do, whatever latest file that we have, which is a.txt, it's going to remove this file temporarily and it's going to put on some, let's say, shelf. Okay. So now this file is not present, and now we can go ahead with creating the b.txt, creating the file, writing the file, then like adding it, then committing it and pushing it. Once we have pushed b.txt, then we have to run the command git stash pop. What this is going to do, it's going to bring back the a.txt file, whatever we have written inside it from the shelf back, and we can continue editing it. Okay. So basically it's useful. Let us understand a scenario. Let's say that I am writing some file, let's say a.txt. I am writing some file, let's say xyz or something, and after I have written something, I am almost going to commit it, so I just add the file git add dot. Then I realized, okay, I have to switch back to some other branch, make some changes there, and then I have to come back to commit these changes. Okay. In that case also we can use git stash, but this will be more clear once we do hands-on. So let me show you. Currently we are on main branch. Okay. So we have these many files. Let me run git pull also. Okay. So we have now all the files available. So now let's say I created some new file, touch, let's say a.txt. Okay. And I will edit the file a.txt, let's say. Yeah, choice one. I added this file, I written something and I saved it. Now I realized, okay, before a.txt, I have to add b.txt. And if I run ls, then you can see a.txt is present, but I don't want it right now here. And but I have written some content also inside it, so I don't want to lose the content of the file as well. So in that case, what I can do, I can run git stash. If I run this, sorry, I think I'm missing something. Sorry. Yeah, so we have not tracked the file, right? Because we have not run the command git add dot. Okay. So now if I run git status, you can see now file is tracked. Okay, tracked by git. So now if I run git stash, so it's going to put the a.txt to shelf. And now if I run ls, you can see now a.txt file is not at all present. Okay. So now what I can do, now I can add a new file vi b.txt, and let's say I'll write stash example, and I will save this. Okay. So now we have b.txt. Okay. Also, just remember, team, every time I ran touch first and then vi. But in Linux, I told you that using vi command, we can create the file and directly open in editing editor mode also. So directly you can run that as well. Okay. So here b.txt is present. Now we can add this file and we can commit this. Added b.txt, git push. Okay. So now that is done, now we can bring back the a.txt file. So for that, I can run the command git stash pop. And now if I run ls again, you can see a.txt file is present here. And here that a.txt file, now I can commit the a.txt file. So I can run git commit -m added a.txt and git push origin main. And now a.txt is also pushed. So for some temporary time, if you want to like push some work or push some file on hold, then you can go with git stash pop. But this is the basic example of git stash and pop. There could be little bit complex example also. For example, let's say we have this. Okay. So let's say I created some new file vi c.txt. Okay. And let us write stash, save this. Okay. Once I have saved this, so I can add this as well. Git add dot. Okay. And I'm putting this on shelf. So for that, I can run git stash. Okay. So that file is gone, right? Now let's say I added some other file vi, let's say d.txt. Let us just say write something. And commit this git add dot git commit -m file git push resume. So we have added new file which was d.txt. Okay. Let's say again I created some new file. Let's call it as vi d.txt, and we are going to write something git add dot. Okay. So we have a new file e.txt, while c.txt is already on shelf. So if I run this command git stash, now git stash command, what it does, it's going to put the latest commit on stash. If I run this, now it has added the e.txt file on stash. And here, if I want to see like how many stashes are there, I can run the command git stash list. Here we can see that there are two files that are currently on stash. Okay. So what I want, my requirement is that I want to like bring back one file at a time, or specific file. So for that we can run the command. We have this specific command git stash pop, and then the specific stash ID. Okay. So now only c.txt is brought back while e.txt is not present. Okay. And let me just comment this. Get commit -m dot txt. Okay. And we can bring back the other also. e.txt is also back, and we can commit those as well. Okay. So in this way, you can put multiple files or multiple contents of the file on stash using this command, using stash and pop command, and you can bring back those as per the requirement. Okay. So these are the two scenarios. Now talking about the next scenario. So next is like basically merging. You just saw that if you want to merge the contents of a specific branch to other branch, then we can do it using the git merge or git rebase. But let us say a scenario where we have, let's say, this is my develop branch and this is main branch. So here, let's say I have done 3 commits: commit 1, commit 2, commit 3. In C1 I added, let's say, mm, 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 g.txt, and commit 2 I added h.txt, and here I added f.txt. Okay. So if I run the command git, if I run go to main branch and if I run the command git merge develop, then all these files will be added to main. But my requirement is that I want to merge only this file. Okay. So how I can do that? So for that we have a concept of cherry pick. Okay. Now cherry pick, from the name itself, you can understand ki specific thing we are going to pick. Whichever specific committed file we want to merge into main branch, that we can do using this command. Okay. So let me show you how we can do that. So let's create a new branch from main. Git branch, let's say M2, and I will switch back to M2. Git checkout M2. So now we are on M2 branch. Now what we can do, we can create some files here, and let's say as of now we are having these many files and files. Okay. So here I can create git g.txt. Sorry. See, we can add this dot git commit on g.txt. One file we have committed. Okay. Let's create next file h.txt, add dot. Similarly, one more file we can add j.txt, add it. Okay. These files are added and we can push the changes. Git push origin M2. Okay. So we have these new files added in M2 branch, G, J, and H. Okay. Now I can run the command git log --- one line. So we have new files added G, H, and J. Okay. Whose IDs are there. Now what I want, on main branch, I just want to add this file h.txt. I want to merge only this file from this main M2 branch to main branch. In that case, first of all, we are going to switch to git checkout main. Okay. One more thing I'll tell you. So for merging, let's say we have 2 branches, develop and main. Okay. Now develop is also created from main, so it can be easily merged back into main. But let's say we have some other branch like, let's say, feature, and it is not created from main, so we cannot merge it back to main. Branches are going to merge to specific branches only if they are created from them. Okay. So now, and here we can check git log --- one line. So in a main branch, we have this is the latest commit, and we want to add this one. So what I'm going to do, I'm going to copy this ID first, and on main branch I'm going to run git cherry pick, then the ID that we have copied. Okay, and here now you'll be able to see that h.txt is merged from develop branch to main branch. Okay, so if you want to merge specific commits from another branch to some other branch, in that case you can go ahead and use git cherry pick. There are different versions of git cherry pick where you can merge a range of commits. For example, if I want to merge from these 4 commits, so for that also we have different command which I'll be showing later on. Okay, but yeah, this is the specific scenario where we could use this kind of option git cherry pick to merge specific commits from one branch to other. Okay, there are other concepts also in git like reset, revert, then merge conflicts. Okay, that will be also taught, but now let me explain you about the branching strategies that we have. So 2 of the branching strategies I'm going to explain now. First is going to be the general one that exists almost everywhere. Second is going to be the branching strategy that was being used in my previous company. So this will give you some real and good time, real time ideas. Okay. Firstly, let us understand about the environments. Okay. So generally, we are supposed to have 5 environments, out of which we have dev, QA, PPD, prod, and DR. Okay. Now, dev environment. As of now, I'm talking about environment, not branches. Now, dev environment is the environment where we are going to do all the development work. For example, if client says that I want to add some new button, I want to add some background color, I want to add some background image, or I want to perform any kind of modification on the project or the application, so first level of development of the code is going to be happening here in development branch. Okay, once it is tested by the developers, then it is going to be merged to QA branch. What is QA branch? QA branch is QA environment. So that here basically when I'm referring to merging, here I'm saying that that code will be promoted from this environment to this environment. What will be new changes to QA environment? So here all the things will be done. In addition to that, there will be functional testing, and there will be some other kind of testing also. The like core testing, different kind of testing will be there. While in development environment, we are going to have mostly automated unit testing. Okay, but here we are going to have different kind of testing, out of which most important is the functional testing. Okay, then if everything is fine here, then we are going to move the code from here to here, promote the deployment from here to here. Also, in case if everything is not fine in this QA environment, also just for the clearance, each of this environment will be having their branches also. Dev branch will have dev branch, QA will have QA branch, PPD will have PPD branch, prod will have main branch, DR will have DR branch. Okay, so if inside development branch, if everything is fine, code is fine, then we merge the changes from here to here. Okay, and here main task is the QA stands for quality assurance. That means we have to perform different kind of testing, out of which functional testing is quite important. So we have to make sure that we are checking the functionalities of the application or the website, whichever we are having, making sure that it's working fine. In case it is working fine, we can directly merge the code from here to here. In case it is not working fine, then here we are going, like in case we found some bug, so here immediately we are going to create a branch known as bug fix. Okay, and then developers are going to write the code to fix the bug that they have, and then this bug fix branch is going to merge back to QA branch. Okay, and then it's going to test it again, and if everything is fine, then we are going to merge the code to PPD. Also, when I talk about in dev environment or dev branch, we are going to have the initial deployments. So let's say that we want to add 3 features: feature 1, feature 2, feature 3. So 3 team of developers is going to work on 3 features. So for that, they are not directly going to write the code or push the code to dev branch. Initially, they are going to create 3 branches from dev branch: feature 1 branch, feature 2 branch, and feature 3 branch. And they are going to develop the code in these branches, testing it in their local. And if everything is fine, then only they are going to merge it to dev branch. Okay, so once here also everything is fine, and QA environment also everything is fine. So we are going to merge the code from QA to PPD, and PPD is basically a kind of like mimic of the prod environment. Prod environment is the live environment. or the environment where client is like seeing like checking the application, or like let's say we have some let's say we have Mintra application. So when we say we are going to deploy it to prod environment, that means we are going to make it live so that public can access. That means we need to make sure all kind of testing, all kind of bugs or any kind of issues should be fixed before we deploy to prod. So when we have ppd branch and ppd environment, it is basically same to same as prod environment. Why we are keeping it same? So that before we release the application to live environment or live public, before that we should be able to see how my application is going to perform in live environment. So it has the same environment as prod. And one most important thing that we are going to do here is known as load testing. What is load testing? So generally, I know that my application, my website is going to be visited by so many people, thousands of people. So I need to test how my application is going to work or behave under load. So that I need to like create some like using some situation. I need to create like a fake like multiple users, fake load of users, so that I can test how it's going to perform in real environment. So like once it is load testing is done, and once we have seen that how application is going to behave in the ppd environment, then we can merge the code from ppd branch to main branch, so that now here the code that we have is ready, completely ready. It does not have any kind of issues, and it is ready to be deployed to prod environment or the live environment. Okay. But sometimes it happens that this environment could have some critical issues. Firstly, we need, as I say, we need to make sure that when we are deploying the application to prod environment, we need to make sure that it is not having any kind of issues. But sometimes due to some like other bug or some sudden thing, there could be some issues. So this is our priority that we should be fixing it. So for that, what we have to do, we have to create a new branch which we are going to call as hotfix. Hotfix means this branch basically refers to that this is a critical issue and this issue needs to be fixed immediately. That's why we are calling it as hotfix. So as soon as immediately hotfix is fixed, we are going to deploy the merge the changes from hotfix branch again to main. Then we are going to deploy to prod environment, and then we are going to verify and monitor. If everything is working fine, then we are going to merge the code from main branch to disaster recovery branch. What is disaster recovery? If anything goes wrong with main branch, then we can direct the traffic to disaster recovery. That is why I was saying ki until unless everything is fixed in main branch, we should not be merging the code, because main branch and dr branch are supposed to have same version of code. Okay. When I say same version, that also we have to do. See, basically when we do, let's say we have Kubernetes clusters. Okay. So we are going to have two Kubernetes cluster. One is the for main, one is for dr. So when if anything goes wrong, and let's say this is user. Okay. This is user. By default, it is pointing to here. Whenever a user puts the URL mentra.com, it is pointing, it is the user is taken to the application or website that is deployed in main prod environment. But if anything goes wrong, then immediately we redirect the traffic from here to disaster recovery environment, so that temporarily for the time being where main prod environment is getting fixed, for that time being application is not going down and users are able to access it. But there are a lot of things involved. For example, the database. Okay. So database is basically if anything goes wrong with main the prod deployment and prod is not working fine, then we need to make sure that we have a backup of database, so that it can be connected to dr environment as well, so that clients are not facing any kind of issues. Okay. So this is the general scenario. Let me summarize it again. This is how it happens. We are going to have dev environment and dev branch, qa environment and qa branch, then ppd environment and ppd branch. Then we have prod environment and prod branch. And then we have dr environment and dr branch. So each of these branches are referring to their environment, and when code is going to deploy, so it's going to getting deployed from here. And one more thing, team, from here, once everything is fine, like if deployment is working fine and we have merged the code from main to dr, then again from here to here we have to merge, so that dev also contains the updated code for the next iteration. Now what is going to happen? The flow will be like that. Let's say one feature needs to be added. So first of all, we are going to create a feature branch on which developers are going to write the code, and developers are going to test the code first in their local, and then only this code will be this feature one branch will be merged back to dev, and then we are going to deploy to dev environment. Just to the main point of like deploying in dev environment is to check if the application is going to work or not on a cluster, the kind of cluster where we are going to perform deployment. Once that is done, then we are going to merge the code from dev branch to QA branch, where we are going to perform different kind of testing, out of which functional testing is quite important. And the pipelines written for this, since this QA branch or QA environment is specifically for testing, so the pipelines also written for QA is going to be most of the steps in pipeline are going to be written by testers, because for testing different kind of pipeline is written. If code is fine, everything is running fine, then we are going to merge the code from here to here, where we are going to deploy the application to ppd environment to check how the application is going to behave in the actual live environment, which is the prod. So ppd environment and prod environment are actually same, so that we can see how it's going to behave in the prod environment once everything is fine. And here also we are going to do load testing, so that we can see if our application is able to handle multiple, like so much of load or not, because traffic is going to come a lot. After that, we are going to merge the code from ppd branch to prod branch, or mostly it's going to be main only, main branch. So we are going to merge the code here, then we are going to uh, deploy the application from here to here, and we are going to monitor it from some time, because until unless we can see that this deployment is stable, then only we are merging the code from main branch to dr branch, and then we are going to deploy to dr also. And drc, generally most companies they might not be keeping dr. Why they are not keeping dr always? Because it's not, because it's going to be very costly if you are having multiple clusters, if you are doing multiple deployments. Because see, once dev deployment is done, we can like stop the deployments, stop the application pods and all. Here also we can stop, here also we can stop. But disaster recovery main task is to make sure that if anything goes wrong, we can point the user, or we can point the traffic to disaster recovery. That means it needs to run always. For that reason, not many companies are ready to maintain a disaster recovery separate cluster. Okay. And once this is done, then we are going to merge back to dev, so that dev can have the latest code. So this is the general scenario that you have to explain. And now I'm going to explain one scenario, that the branching strategy that we followed in my company. So as I say, ki not all companies will be like that, that they can have multiple environments, because managing multiple environment or hosting multiple environment, it's going to be very costly. So in my company, in because the number of applications that we have deployed on Kubernetes cluster, that was around 600. So if you have 600 applications, then you cannot have multiple cluster and manage so many deployments. It's not easy. So in that case, we were having just two clusters and two branches. One was QA, second was prod environment. For that, we were having we were having like QA branch, sorry, QA branch, and here we were having main branch. Okay. Now, how things were happening? Let me explain you. So let's say and this cluster or this branch, it was basically this environment. It was mixture of having the we were doing dev work, we were doing QA work, we were doing PPD work here also. That means all kind of testing, all kind of building, all kind of initial development, everything we were doing in this only. So how it was happening? Let's say we developers have written or added all the feature, and now QA branch is having the latest code that we are ready to deploy. Okay. For example, let's say initially this will be happening. Let's say two feature branches were created by developers. They wrote the code, they tested it in their local, and then they merged it back to QA branch. Okay. Now, once it is merged, then we can go ahead for deployment. Okay. So for deployment, what was happening? First, we created new branch which was known as RC1. RC1 means release candidate 1. That means this is our first candidate that we are hoping that it will be fine. So once we create release candidate 1, we are going to this branch. Using this, we are going to deploy to QA environment, QA cluster. Okay, and then we are going to perform all kinds of testing. All kind of testing means functional testing, unit testing, then load testing. Everything we are going to see. If we are seeing that some bug is there, if we are able to see some bug is there, then we will be creating a new branch which is bug fix. This we are creating from RC1. Then we will fix it. Okay, then we will fix it, we will merge it back to RC1, and then RC1 will be merged back to here QA. Now this time, once new code is fixed, then we are going to create new branch which is going to be RC2, which is release candidate 2. And then we are going to deploy this. Using this branch, we are going to deploy the application to QA environment, and again we are going to run the test. And we need to make sure that if you are able to find any kind of issues or not. So if again any issues found out, then we are going to create bug fix this issue, merge it back to QA, create third time after fixing the bugs, we are going to create RC3. Now this process of creating release candidates used to go in our case RC1 to RC4. And this was happening within like for time duration of 1 to 1.5 months. And in this, we need to make sure that all the issues are fixed in RC4s. That means the last release candidate that we are going to have, it has no issues and all the bugs are fixed. Once we have done that, and once we have tested the deployment also in the environment, everything is fine, then we are going to merge this RC4 to QA, and then we are going to merge it to main branch, and then we are going to deploy to prod environment. This was happening. The sad thing here that we did not have any kind of DR environment. So if anything, usually nothing used to go wrong, because whenever we perform any kind of deployment, we made sure that everything is fixed and no bug is there. And if even if some issue happens, we need to make sure, we used to like launch a broadcast kind of thing, that some issue is happening and we'll be fixing it within an hour or so. So we need to make sure that within 1 hour we used to fix all the issues. So this was happening in our case. Okay, and these are the two main branching strategies that I would suggest to learn. In interviews you can explain this, but in case they ask, in case like they ask something, this is like general strategy, what else you can explain, for that you can just explain this one, because this is the real time one and I have worked with this also. Hello team, so today we are going to understand git reset different types with proper demo, so that we can understand very easily. Okay, first thing that I would show you is git log, so we can see how many files are present, and like, so that we can compare basically afterwards. Okay, so first thing, currently I am on a feature branch where I have this many commits, right? So, and if I run ls command, you can see these are the files currently existing in feature branch, different file names 1 2 3 4 like that. Okay, till 11, right? So now what we are going to do is run do git reset basically, and I'm gonna explain you what are the things happen that once you run the git reset command. Okay, so before that I would explain you something else. Okay, so you remember, like when we are using git to publish our files or publish our changes, what are the main stages that happen, right? First thing that we do is like create a new file, right, by running the command touch or any other command, vi also you can use. But basically first we need to create a file which we want to push into git repository, remote repository, right? Then what we do, we put that file into staging area. By staging area basically we mean we run the command git add dot or git add file name, right? So when we run this command, the files that we want to push go into staging area. Staging area is a temporary location that exists just before the commit stage. Okay, so next stage we do is like git commit and a specific message. Then what happens, the file that was in staging area, it goes into committed mode. Okay, it is now committed and it's like ready to push. And final command that we run is git push origin branch name, and then we push the file to remote repository. Okay, let me show you with proper example. So let's understand it with a demo. First of all, what we are doing is creating a file. Let's say I'm creating a file named 16, right? Once I create the file, next thing that we need to do, okay, before anything, let me run this command git status. Here you can see that these are untracked files. Okay, they are not in staging area. Okay, so we need to add these files into staging area. We need to run git add file name or git add dot. Okay, so let us run git add dot. Okay, Now again, if I run git status, you can see these files are currently staged. They are in currently staging area, and next command that we need to do is basically commit these files. Okay, so staging area, you can understand when we run this command git add dot, the files are added into staging area. We are adding the files to staging area using this command, right? Okay, next command is like move the files from staging area into committed mode. Okay, git commit -m, a message like added 16. Okay, if I run now git status, you see nothing to commit, like everything is fine now. Files are moved from staging area to commit area, and final command I need to run is git push origin feature, and the file should be added into feature branch. Okay, let me clear the screen. Yeah, so you can see currently we have these many files 1 2 3 4, like till 11 10 11 15 16, right? Okay, now let me run this command git log -hyphen one line to see the logs. So these are the logs. Okay, now let me explain you what are the things that is going to happen once we run git reset. So git reset is of three types: git reset soft, git reset mixed, and git reset hard. Okay, so I'm going to get started with let's say git reset soft. Okay, so let's say I want to run git reset soft on this. Okay, let me show you what will happen. Git reset -hyphen soft and the commit ID. So we are going to run it at 8, right, when the file 8 was added. Okay, so commit ID I have provided. Click enter. Okay, now to see like what changes happened, we can run the command git status. Okay, now see, notice here, here first of all you can see these files are 9 10 11 15 16. These files are currently in staging area. We can see here, right? This is the status that we get after running git add command. You can see here git add, then we got this, right? That means after adding these files into staging area, we get this. Okay, that means when I ran the git reset soft and the commit ID here, so the files or the commits that happened after this, are back into, are like they were committed. Okay, but they were back into staging area, like commit is reversed, they're back into staging area, right? So now they are into staging area, and now whatever changes you want before commit you can do here. Okay, so this is soft reset, right? Okay, now let me explain you what will happen. ls currently files are existing. If I run git log -hyphen one line, okay, so currently you see since I ran this git reset, so they are removed from the commits, the file after this 8 which we ran, right? So the files or commits after this point are removed from the commit. Okay, they are currently staging area. Okay, that happens when we run git reset soft. Okay, so currently you can see the head is on this file, right? After it, like whatever the 3 commits were there, they are removed from commit. Okay, okay, now let's talk about git reset mixed. What will happen then? So if I run git reset for mixed, you can simply, you don't need to mention anything. Okay, so I'm gonna run the git reset mixed on this file. Okay, if I paste it here, it ran. Now if I run git status, okay, now you see, so we ran it at here. Okay, so since we are running the git reset mixed command here, so whatever commits that were existing after 6 will be taken back from git add also, like they are removed from git staging area also. When file get into staging area, git add, right? So that means if we reverse the git add command, the files will be taken away from staging area, and that's exactly happened here, right? These are the previously files because we did not commit any changes after that, so they are also existing here, right? And here you can see so and so. Okay, That means ki, these files are now back from commit and back from staging area also. Okay. So let me explain you from the example. With git reset, what happens? This 1 second. See, with git reset command, with git reset soft command, files were like taken aback from here. Okay, till here these two steps were visible with git reset. Okay, but when we ran git reset mixed, then files were these steps were also reversed. Okay, these two steps reversed with git reset mixed. Okay, and that's exactly what has happened here. Git reset mixed, it like took the files back from staging area also. Okay, right. But one more thing I will do. Yeah, final type of git reset is git reset hard. If I run git reset hyphen hard, okay, let's say I want to run it on this commit. Okay, added 4. So you know what will happen? Sorry about that. If I run git reset hard here, so what will happen now? Whatever files exist after this, whatever files or commit happened after this will be permanently removed, permanently deleted. Okay, again I'm repeating, git reset soft, what happened? Files will be added into staging area, right? When you run git's files, whatever, like at whatever commit you add, so whatever commit exists after that point. For example, let's get back and understand it one more time. Let's say I ran the git reset command here with soft. Okay, so after this these many commits exist, right? Added 4, added 5, added 6, added 7, added 8. Okay, and I ran git reset here. So what will happen? These files will be back into staging area. Okay, the commit that happened will be reversed, and these files from here to here will be back into staging area. Okay, but let's say I ran git reset mixed here. Okay, I ran git reset mixed here. So what will happen? The commits that happened afterward, they will be like removed from staging area also. Okay, they will be removed from staging area also. But if I run git reset hard from here, then what will happen? These files will be permanently deleted only. Okay, let me show you. So if I run this, click enter, git log and hyphen one line, and you see at 4 we ran like for 4. So after that, whatever commit existed, it just deleted when we ran the hard mode. Okay, so if I just publish these changes, git add dot git commit, hard reset, okay, so if I run git log hyphen one line, you see all those files after like this commit were deleted permanently. Okay, and I hope this makes clear like how this reset happens. Reset happens in 3 modes: soft reset, mixed reset, and hard reset. Hard reset, if you run on a commit, then whatever commit exists after that will be deleted permanently. Soft commit, if you run, then for the at whatever commit you run, so extra commits that existed afterwards, they will be added into staging area, and in case of mixed, they will be removed from staging area as well. Okay, so this is basically what happens with reset. But as I said, key most commonly used is git revert instead of git reset. Okay, so yeah, that will be all for hey team. So now let us understand about git revert. So first of all, what I'm going to do, I'm going to clone a repository so that on that repository we can test our commands. Okay, let me increase the size. So first thing we need to do is clone our repository. Let us go inside it. Okay, and as of now we are having this many files. Okay, so in order to show you like how exactly revert is going to work, what I'm going to do now is create multiple files so that in git revert we have multiple commands. So it's better if I try to show you how git revert works through all those different case or scenarios. Okay, so let me create multiple files, one.txt. I'll add it and I'll commit this. Okay, and again we need to create multiple files as I said, so only we can test it properly. So I'm going to create too many files actually. Okay, so once I create too many files, then I'll be back. So team, as you can see, I have created 10 files. Okay, that means if I try to see the commits now, git log -1 one line, and we can see from here to here I have created 10 files. Okay, so now let's understand the first scenario. Basically what exactly git revert is going to do. Okay, so let's say I want to revert the changes that I introduced in this commit. Okay, this is the commit hash. This code that is existing, it's an id that we like to call as commit hash. Okay, so this using this commit hash we can identify what changes we are done. So from what we know that, okay, while committing these changes, we added a new file one.txt and I want to revert it. Okay, that means I want to undo the changes that were introduced or added with this commit. Okay, so first basic command is we need to run git revert and the commit id. Okay, so if I copy this and paste it here, so what sorry and paste it here, so whatever changes were introduced with this commit, they will be removed. Okay, and the question is, well, like, why it's better than git reset. Okay, because git reset will also undo the changes and git revert will also undo the changes. Okay, how it's better? So the thing is ki when I revert the changes from git revert, what it's going to do, it's not going to disturb the commit from here to here or anyone. It's not going to change the commit. Okay, what it's going to do, it's going to add one extra commit where it will be mentioned ki what changes are reverted. Okay, let me show you. Because when we use git reset, so the commit history is changed, little bit changing will be happening, but in case of git revert, no changing will be done from here to here. Instead, just one extra commit will be added which will mention what revert is done. Okay, let me show you. So I have added the commit hash and the get revert command. So my target is to revert the changes done with this commit. And what changes were done? I added one.txt file. So those file should be removed. Okay, let us see. As soon as I enter git revert commit hash, it took me to a terminal where I need to provide information about what changes I am doing. Okay, so here you can put the information what changes you are doing. So I'll just write the information something like that key removed one.txt. Okay, and let me remove this quotes also so that we can understand what exactly we have done. Okay, and I will save this now. Once we have saved, you can see deleted mode. So now revert has been done. Now if I run ls command, you can see from 2 to 10 you can see, but there is no one.txt. That means in that commit we added one new file which was one.txt. It is like undooed, or basically you can say it's removed. Okay, also if I run this git log -1 one line, you can see that here also it is existing, right? This commit has not been changed. Instead, we have added one new commit which has the information like removed one.txt. Okay, so basically the main idea of git revert is to keep the commit history linear. It's not disturbing anything, right? So that is one way of doing commit revert. Okay, now let's talk about, we have multiple commits that we want to revert. In that case, what we can do, let's say I want to revert commit to I want to revert this commit and I want to revert this commit. Okay, so what I'm going to do, I'm going to run the command git revert and first commit hash, which is this one that I want to revert. I'll copy this, paste it here. Second commit which I want to revert, which is this one, copy, paste it here. And third one, let's say this one. Okay, so I'll copy this and I will paste it here. Now, so when you want to do multiple reverting of multiple commits, you can use this method. Okay, click enter and one by one we need to provide the message what changes we are applying. Okay, so I won't modify, I'll just save this Then you see second terminal opened for the second commit hash. This also I will just save, and now this is for third commit hash, right? Now I have saved, and now if I run ls command, you can see file 234 has been gone. Now we just have 5 6 7 8 9 10 file, right? Again, if I run this git log hyphen hyphen one line, here you can see from here to here nothing has been changed, but here we have added 3 new commits which are basically reverting the previous commits. Okay, so again it's everything is linear, we are not disturbing the previous commit history, we are not changing that. Okay, now let's say my target is to remove the basically revert the changes from here to here in one go. Okay, so one command that we saw, get revert multiple hash names, right? But I have a range, basically I have a range that I want to remove, revert basically. So what I can do, I can type get revert. Okay, and I want to revert the changes from 5.txt. Basically I want to remove 5.txt to 10.txt. So first of all I need to copy one below before this commit, like from here to here I want to revert. So before 5 we need to copy the commit just below 1. Okay, and put a 2 dot. After putting 2 dot, put the last commit which you want to revert. Okay, now what is going to happen from here to here, whatever commit change, whatever changes were introduced in these commits, they will be reverted. Okay, this is how like you do for range. Okay, and if you want to make sure that this is also removed 5.txt commit, then you need to select the initial point as one below commit. Okay, now after running this, again multiple terminal is going to open because we have multiples. So I'm just going to save all of them one by one, and done. Now if I run ls, you can see all those range like removed. Okay, and if I see the git log hyphen hyphen one line, you can see new revert has been added from here to here, revert commit. Okay, so this is how commit reverting of the commit can be done. And just remember that revert is much better than reset. Okay, and I hope you have watched the reset videos. Okay, so yeah, this is how we can do. Great, I hope it is fine, and you can I would suggest you just practice it one time. Okay, and yeah, one more scenario, let's talk about one more scenario which is quite interesting. Sometimes it is possible that if you are doing like reverting multiple changes, multiple commits, there could be some conflict. Okay, so how do we resolve the conflict? So now let me show you that. Okay, so for that I have created one small scenario. We are going to create a file.txt. Okay, inside that we are going to put some content, and we are going to do 3 commits. In first commit, what I'm doing, I'm just writing line 1, line 2, line 3. Okay, in second commit I'm modifying the line 1, and in the third commit I'm modifying line 1 and line 3. Okay, so let me show you what is going to happen. So first we are going to do this commit, create the file, and this is done. Second thing that we need to do is run this command to basically modify the file. Okay, this is also done. And one last thing, third commit that I'm going to do, it's also modifying the files. Okay, now if I run git log hyphen hyphen one line, you can see we have 3 new commits, commit A, commit B, commit C. Okay, what changes did we do? In commit A we added a file. In that file we added 3 lines, line 1, line 2, line 3. In commit B we added we modified the line 1. Okay, line 1 changed in commit B, and in commit C we changed line 1 and line 3. Now what I want to revert the changes from commit B. Okay, but there will be conflict. Why conflict? Because if you are reverting, we are expecting that change should be coming something like line 1, but here the thing is after reverting this, commit A also edited the line 1, commit C also edited the line 1, same line is being edited, right? So in that case, error will come, commit conflict will come. So let us see how we are going to how we are going to solve it. Okay, so first of all, let us try to revert the commit b, and commit b hash is this one. Copy this, paste it, click enter. Sorry about that, sorry about that. Okay, you can see conflict here. Why conflict is coming? Because in file.txt there are two commit has been done on the same line. Okay, for example, uh, if I open the file now, you can see line 1 here and this one. Okay, so we need to fix it. Okay, what we can do, so let us modify what I want the content. First of all, I'll remove this. Remove this also. So this is the content that I want. Okay, so I will save this. Once I have saved that, you can see here what is saying, we need to add it. Okay, so I will run the command git add dot. Okay, so we have modified the file, we have fixed the conflict that was coming, right? Now let us see the steps. So after resolving the conflict, mark them with git add. So we have done that, git add dot. Then we need to click on this, we need to continue the reward part. Okay, so I'll copy this, paste it here and click on continue. Okay, and let me save this, that we are changing, we are reverting the changes introduced by commit b. We have done that. Now if I run cat file.txt, we should be able to see this one. This is the now final, like after reverting and after uh, fixing the conflict, we can receive, this is the content of the file that we fixed. Okay, so this is how, like if if conflict comes, in that case you can simply vi the conflict, run the git add command, then run git, you need to run git revert continue. Okay, but let's say that like I saw the conflict and I feel ki I don't need to resolve it, and I don't need to revert. Okay, so in that case what I'm going to do, in that case you will write git revert hyphen hyphen abort. This will abort, like this will basically abandon the revert part. Okay, so yeah, this is how you can work with git revert.